Today, we'll walk through the OpenVox Unified Communications Platform, UCP, and focus on how it's built and how it's deployed in real environments. The core idea is integration, bringing data, voice, and video onto a single modular platform while still supporting the interfaces enterprises actually have in the field. As we go, I'll cover the architecture, the module options for scale and connectivity, and then several case studies that show what this looks like in practice. Most enterprise communications projects run into the same four problems. First, legacy analog systems don't naturally fit with modern IP networks, so teams end up maintaining two worlds at once. Second, many systems were designed for a single site, which makes multi-location collaboration and consistent dialing plans difficult. Third, fixed capacity solutions become a constraint. Growth forces forklift upgrades instead of incremental expansion. And finally, fragmented vendor ecosystems increase integration effort, operational complexity, and total cost. UCP is designed specifically to remove those constraints without forcing a disruptive rip and replace. UCP is a modular, chassis-based platform that integrates data, voice, and video using hot-swappable control and service modules. There are three differentiators to keep in mind. 1. You can mix and match telecom interfaces, analog, digital trunks, wireless, and IP, so the platform adapts to the environment instead of forcing a redesign. 2. It uses an x86 plus domestic architecture approach and supports dual controller redundancy, which is critical for uptime. 3. It's built for true convergence, IPPBX functions and business system integration running on one platform. So you simplify deployment and ongoing management. The product portfolio is designed to scale from small deployments to enterprise density, roughly from 20 users up to 4,000 plus. The lineup starts with UCP 1202 as an entry compact option, then UCP 800C5 for small business standard deployments. UCP 2102 is the mid-range platform when you need more expansion and interface diversity, and UCP 4131 is the high-density enterprise-grade system. The key takeaway is that capacity and connectivity scale progressively, so you can choose a chassis that matches today's load and still leave room for structured growth. At the center of UCP is the control module, the CCU, which determines compute capacity and call handling scale. There are two main options here. CCU N Alder targets up to 800 users and about 200 concurrent calls. CCU L TGL scales to about 4,000 users and roughly 800 concurrent calls. Beyond raw capacity, an important architectural point is that multiple CPUs can be deployed per chassis. That enables redundancy and also supports clustering approaches, so you can design for both performance and high availability, rather than treating uptime as an add-on. Service modules are how UCP connects to the real world, and this is where it becomes practical in mixed environments. For legacy phones and PSTN access, AIU8 or AIU16 provides analog FXS and FXO. For carrier digital trunks, DTU supports E1, T1, and J1. WTU adds GSM, WCDMA, or LTE for wireless trunking and backup. ACU supports audio broadcasting scenarios. DCU extends data connectivity, Ethernet, and HDMI when you need that convergence on the same platform. And MIU provides multi-interface expansion, so you can scale the mix of ports as requirements change. The overall point is coverage. You can design one chassis to fit legacy, IP, carrier trunks, and backup paths together. In this educational institution, the requirement was a stable telephone system with the basic PBX capabilities, internal calling, transfers, department grouping, and flexible outbound routing. The solution was built around a UCP 1900 with a CCU, plus an AIU 80 module to connect to the PSTN. A WTU module was added to provide a wireless backup channel. To preserve existing endpoints, IAG802 gateways were used to bridge the existing analog phones into the system. The value here is straightforward. They upgraded to IP PBX capability immediately, kept existing phones, and avoided rewiring or disruptive infrastructure changes. This medical public health center had a much more demanding profile. 9 medical zones, over 200 concurrent calls, and telecom-grade stability under 7/24 operation. The architecture used UCP2.20 in a dual-machine hot standby design, so failover is seamless. Capacity came from 4 DTU modules delivering 4 E1 trunks to support the concurrent call load. On the access side, MAG 2000 gateways unified the wards, nurse stations, and pharmacies into one managed communication system. The operational value is reliability and control. Hospital-wide unified management with uninterrupted communications where downtime simply isn't acceptable. In this bank credit card center, the challenge was organizational change. Interconnect an old and a new office building without disrupting existing numbers or established dialing habits. The new building deployed UCP2120 with DTU for E1 access, plus wireless backup and MAG 2000 gateways. The old building used UCP431 with MAG 2000. The two sites were interconnected using SIP protocol over the enterprise network, so dialing and call handling feel like one system rather than 2 islands. The value is a one network, one system experience. Seamless cross-building communication and reduced relocation and transition cost. This 40-seat call center needed to integrate an existing 400 service number, support 40 agent seats, and run continuously with stable operations. The design uses UCP2120 with dual-control hot standby to remove single points of failure. DTU provides multi-E1 trunk capacity, and wireless connectivity is added as a backup path. Extensions are configured for the 40 seats, with flexible skill group configuration to match call center operations. The resulting value is a smooth migration of the 400 number unified seat management and better operational visibility, while meeting the core requirement of 7/24 availability. In this large medical enterprise, the goal was scalable voice interconnection between headquarters and branches, with unified platform management and consistent call quality. The HQ side used UCP4131 with dual servers, RAID 1 and DTU, plus MAG 2000 expansion as needed. Branches used UCP1600 with DTU for an E1 dedicated voice network. Sites were interconnected through a VPN-based private network to achieve toll-quality calls between regions. The value comes from 3 outcomes. Cross-region calls feel like internal calls. Centralized management reduces total cost of ownership, and the architecture removes single points of failure through dual server design and RAID 1. To close, there are 3 practical reasons organizations choose UCP. First is flexibility. The modular design lets you combine analog, digital trunks, wireless, and IP in the same chassis, so deployments fit the current telecom environment and can evolve over time. Second is reliability. Dual controller designs, RAID where needed, and multipath redundancy support high availability architectures for mission-critical operations. Third is scalability. From about 20 users to 4,000 plus, and from single-site deployments to multi-location interconnection. The overall message is simple. You can build unified communications infrastructure with confidence because the platform design matches real constraints in the field. For detailed product specifications, technical documentation, and deployment consultation, please visit our website at w.openvox.cn. Our team is ready to help you design the right unified communications solution for your organization. Thank you for your time. We look forward to partnering with you on your unified communications journey. Visit w.openvox.cn to get started.